Hello, this is Mr. Stein, and in this video we are going to go through the unit and graphs. We're going to do two graphs. We're going to graph the relationship between a number and its square root, and the relationship between a number and its perfect square. The point of this is that you should be able to graph relations. So the part one is the perfect squares table of values. So these are going to be perfect square numbers. Let's take a look at some perfect squares. I'm going to choose my x values. I can choose any x values that I want. Then I'm going to square them. -3 squared is 9. -2 squared is 4. -1 squared is 1. 0, 1, 4, and 9. If I want to write this relation as an equation, I can write it like this. Y is equal to x squared. I can also write this as a function. F of x is equal to x squared. All right, our square roots table of values is going to be a little bit different. I'm only going to put in easily square rooted numbers. All right, I'm going to start off with -4, -1, 0, 1, 4, 9, 16. All right, what's the square root of -4? Nothing. It's an error on your calculator. What's the square root of -1? Nothing. It's an error on your calculator. What's the square root of 0? 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. If I want to write this relation as an equation, y, our value y is equal to the square root of x. If I want to write this in function notation, our function on x is equal to the square root of x. Okay, now we're going to graph these two. Now looking at this grid, the grid goes up to 24 on each side. So we're just going to make every square worth 1. So what I'm going to do, I'm going to put a mark at 10. And a mark at 20. So I'm just going to put a mark at 10 and mark at 20 just to help me out here. And I'm going to do the same thing this way, up and down. So do this as well. And to the negatives. Now, you don't actually have to do the negative y-axis. You don't have to do down here. Right? Take a look up here. Look at our y values. We don't have any negative y values here, and we don't have any negative y values here, so we don't need those negatives. We just need quadrant 1, that's what this is called, and quadrant 2 on this side. All right, so I'm going to graph my first function right here in purple. I should have chosen 2 different colors at the start, but I'm choosing them now. My first graph is going to be purple. So it starts at 0, 0. Then it goes through 1 and 1 right there. Then it goes through -1 and 1. Then it goes through 2 and 4. -2 and 4. Do you see how it's symmetrical? Then it goes to 3 and 9. -3 and 9. Then it goes to 4. 1, 2, 3, 4. And 16, 10, 11, 12, 13, 14, 15, 16, 11, 12, 13, 14, 15, 16. And it goes to -4 and 16. So the graph looks like this. Now we just complete this graph with a nice curve. Like this. Put arrows because it can keep going in any direction. Well, not in any direction, in those two directions. And we connect the dots because it makes sense that we could have, let's say, 1.5, and we can square 1.5 and get a value. This is continuous data. So we can find the value of the function at any point of x. We can do 4, we can do 4.5, we can do 5. We can do any value for x, and we can square any value for x. So we join the dots. All right, let's choose a different color for part 2, the square root. Well, we don't have to do anything out on the negative sides because there's nothing there. But it goes through 0, 0, same as the other one, same as our perfect square. It also goes through 1, 1. Then we go to 1, 2, 3, 4, 4, and 2. Right there, 4 and 2. So 4 on the x, 2 on the y. Then we go to 9 on the x and 3 on the y. Then we go to 16, 11, 12, 13, 14, 15, 16, and 4 right up there. Then we can join these dots together. And if you look at this graph, it looks just like half of our purple graph, only rotated 90 degrees, or mirrored. So those are the two graphs. Question number 1. What happens when you try to find the square root of a negative number? Well, you get an error, right? Try to find the square root of a negative number, and we get errors. -4 square rooted is error, -1 square root is error. Now we're going to do something. We're going to write the domain and range of each function. For our purple function, the domain is how far left and right this purple function can go. So can we square -10? Yes, we can square -10. Can we square 10? Yes, we can take any number and square it. So the domain, we write it like this. It's our x values. And our x values could be any number, any real number. And we write it like that. So this is the left and right, left to right. How far left and right the graph can go. Our range is how high up or down our graph can go. You can see our purple graph. Our purple graph only is in this part of the y values. It has a bottom. Right here's the bottom. So our purple graph goes down to y equals 0, but nothing lower. So our range for our purple graph is y. Y has to be bigger than or equal to 0, but y could be any real number that is bigger or equal to 0. So we write it like this. This is up and down, how high up and down that can be. So those are the domain and ranges for our purple graph, the perfect squares. Now we're going to do the domain and ranges for our blue graph, the square roots. Remember, our domain is how far left and right it can go. So let's look at this guy. How far left and right? Well, it can't go smaller than 0. It has to be larger than 0. So our x values, such that x has to be larger than or equal to 0. And x could be any real number. We could square root decimal numbers and things like that. So that is our domain for x. It's how far left and right it goes. Our range for our x values is how high up and down it goes. You can see that it goes down to 0. That's the lowest point. and then it keeps going up. So it starts at 0 and it goes up. So our range is all of our y values such that y is greater than or equal to 0 and y is any real number. Now don't worry if you don't fully understand domain and range. We are going to be working on that this unit, and so you'll pick it up by the end of the unit. Right. If you have any questions,